Welcome back to another revision video from the Maths classroom. In this video, we are going to be looking at circle theorems. Before we look at the circle theorems, it is a good idea to make sure that you are confident that you know what all of the different parts of a circle are called. The circumference of a circle is the distance around it. It can be calculated using the formula pi times diameter. The diameter is simply a straight line segment that passes through the center of the circle that spans the entire length of the circle. The radius is the straight line distance from the center of the circle to any point on the circumference. It is half the size of the diameter. The chord is simply a straight line segment whose endpoints both lie on the circle. Finally, a tangent. A tangent to a circle is a line which touches a circle at just one point. Now let's look at the theorems. One circle theorem states that the angle at the center of the circle is double the size of the angle at the circumference. For example, if the angle at the circumference was 30 degrees, then the angle at the center would be 60 degrees. The second theorem states that angles in the same segment are equal. The angles at the circumference subtended by the same arc are equal. As long as the 2 points are in the same segment, it doesn't matter where on the circumference the points are, the angles created will be equal. Theorem 3 states that the angle at the circumference in a semicircle is a right angle. This theorem can be linked back to Theorem 1. The diameter is a straight line at the center of the circle, which is of course 180 degrees. The angle that is at the circumference is half of this. So the angle created is 90 degrees. A cyclic quadrilateral is a quadrilateral drawn inside a circle. Every vertex of the quadrilateral must touch the circumference of the circle. This theorem states that opposite angles in a cyclic quadrilateral add up to 180 degrees. Theorem 5 says that the angle between a tangent and a radius is 90 degrees. Theorem 6 also involves tangents. It states that tangents which meet at the same point are equal in length. This point is outside of the circle. The final circle theorem is the only circle theorem that has a name. It is known as the alternate segment theorem. According to this theorem, the angle between a tangent and a chord is equal to the angle in the alternate segment. Now that we have seen all of the theorems, we can have a go at a question. Press pause and have a go. Once you have completed the question, press play and I will go through the answers. Let's have a look at the answers. For lines yp and yx to be equal, the point P must lie where the tangent yxw touches the circle. Part B. For this part of the question we need to use the circle theorem that a tangent and a radius meet at 90 degrees. The line wxy is a tangent to the circle and meets the radius at 90 degrees. Corresponding angles are equal. XA and WB are both at 90 degrees to the tangent WXY. Part C. For this part of the question we need to use the circle theorem that angles at the center are double the angle at the circumference. Angle HBG is 160 degrees, meaning that angle ABW must be 80 degrees. We can then use the circle theorem that a tangent and a radius meet at 90 degrees. Angle WX must be 90 degrees. Now that we have worked out these angles, we can use some basic angle facts. We know that angles in a quadrilateral add up to 360 degrees. 90 plus 90 plus 80 plus XAB equals 360. We can simplify this to give us 260 plus XAB equals 360. We can then rearrange this to give us that angle XAB is 100 degrees.